So the start is brutal, right? So it just goes on. So hello, welcome to my talk. As you can see, I changed the topic slightly because I got more and more tweets like when you will start to talk about femto services. And my secret plan was to start the first talk. It was a Fugcafé in Malmö about micro. The next Pico, femto, atto, and I have no idea what comes after atto, but basically it's the same, right? So whatever the next big thing is, it fits somehow to microservices. So so whatever you put here, micro, femto, and atto, I would say reasonable services would be the better title. But if I name it reasonable services, no one will come. So it is far better to name it somehow more sexy. So this is what all the consulting is about, right? So I'm working with Java 1995 and freelancer since 1997. Spent a lot of time in projects. Actually, this year I even managed to spend more time in projects than the year before because of some optimization strategies. And the optimization strategies are I just try to minimize the trainings. There are just 3 times a year. And today started the online course, Bootstrap Java, so you can go to Parlays and download it if you like. And Airhacks TV, I try to minimize my social activities on my blog, like answering comments. So instead of this, I do once a month a free session where you can interactively challenge me with questions. So this book was actually about microservices I'm using on my blog. This is actually a microservice. But I didn't knew this that time, that was 2009, that microservice is a good name for something. So otherwise, I would call the book probably Real World Night Services, or Night Services is wrong, microservices or something. Night Services is dangerous. Java patterns, not that micro, but one pattern, ECB, is actually a microservice pattern. This is the Airhacks TV, if you like. Tune on is the first Monday of the month at 6 p.m. Lots of fun, free. So Munich. And definition of microservices, what's nice is the first in short, right? And then it's go on. This is from Martin Fowler, and this is absolutely right. So what's all about is developing a single application as a suite of small services. It's running in its own process and communicated with lightweight mechanism. So lightweight, it's a really strange name in Java because in one project it was, I would say, 6-7 years ago in Switzerland, someone showed me on Tomcat, say they have lightweight application server, and the server was lightweight, and the were no kidding, 500 megs. And they told it is lightweight infrastructure because they, and the reason for this, why it was called lightweight, because there was no real application server in place, okay? So then a little bit afraid with the lightweight, but everything else fits well. This is from Wikipedia, and a little bit more, composed of small independent processes communicated with each other using language agnostic APIs, which could be Corba, by the way, but it isn't. And by the way, if you would show someone this in 1999, he or she will point you to Genie, Java Intelligent Network Infrastructure. It was probably the very first specification, which was very micro. And because it was too micro, it never took off, because it was really hard to manage microservices, actually. So, and I always ask question, if I see something new, what is actually the opposite? Let's say we don't do the microservices. Okay, so let's say for unknown reasons, we have application server and Java EE, and because we have Java EE and application servers, we don't like microservices. What is the opposite of this? This is always a good, I think, what I always do, try to see, what is the opposite of this you are saying me right now? And the opposite is this. I actually stolen the slides from the Architecture Airhacks course. And what it is, I was a huge fanboy of the machine, but just because of look and feel. This is E10K, one of the largest servers which Sun sold back then. It costed several millions, no, 1,200,000 euros. And you can buy it right now, or a few years ago, for $2,000. And I actually wanted to buy it as a wardrobe, because I just wanted to, to move everything out, all the motherboards, and it would be cheaper than actually wardrobe if you design wardrobe, but I didn't do this because he had to ship it or whatever. But this is actually the picture I look for, because I just like the machine. Why, I have no idea. In some projects they use it already. And the problem with this, because it was so expensive, what happened back then, the application server were used to save money on hardware. This was the whole issue. So there was 1 year was huge, the whole application, and within the year you got 50 EJB jars and 50 wars and 50 libraries. By the way, libraries in Java land were very, very popular. Why? I have no idea. Everyone loved jars. So the architects, what they always did, try to introduce the more jar, the better, the more modules or whatever. From my point of view, it's like a Java disease, but it was very, very popular in projects, still is. So modularization is paramount. And so what is the opposite of microservices? The opposite of microservices is an ear with several EJB jars, lots of dependencies, lots of wars, the whole application in one place, deployed on a shared server like this. And this is the opposite of microservice. Agreed? Oh, if you have a challenging question, you get a t-shirt from me, AHEX, and the back is more interesting because it's compilable. So there's actually a project which compiles. And I have to give away some t-shirts for the parlays guys, but you have still a view of them. Everyone agreed? So the opposite of a microservice is a huge ear on shared application server running on something like this. This would be for me the opposite. Right? But this is this slide is from, not the slide, the machine is from around 2000. Okay? So actually, so this is the funny part. So in all my talks, I wanted actually to rehear the talks from the DevOps 2 years ago, and so far I think I already talk about microservice without knowing it. What I probably did, I hacked a small application for you just based on war and preached that this application should run on a single application server, and this is our modularization model. And this fits perfectly with microservices. And today morning I got a tweet like, you will talk about microservices, but there is I don't know where I saw, where he saw this. Application servers are about to die because of microservices. I mean, okay, what is the next? Then we get full cycle. Because at the beginning, we had application servers which were not standardized, so every application server was something completely different. So we can move that again, but the problem was, what you are building is absolutely not compatible with another thing. And this was a terrible story back then. Who actually remembers the days of commercial application servers without standards? What I can tell you, it was impossible to be somehow, I'm not expert, so know what they are doing than more with two different vendors. They were so completely different, it was no way. So I really looked forward to J2E because I thought, okay, now we have something which is common to all servers. And it was a huge simplification to me. What I saw now is, application servers are not suitable for whatever reason, so we built something else. And now is the question, if we don't have application servers, what is an application server to me? It's something like all the dependencies on the machine, all the cross-cutting concerns like monitoring, pooling, all the stuff you need is already on the machine, so I have to care about this. I concentrate, I focus only on business logic, put my stuff on the application server, and this basically is. Monitoring, deployment, remoting APIs, they come from the application server. This is for me application server. And Java E is application server with standardized Java E APIs. Agreed, everyone? If not, I mean, so, and now is the question, if someone says application server are dead, so what do we get then? I don't know, you are starting a main method with no pooling, no monitoring, and then, we'll put everything on top of an application, we had it already. So I don't get it. So this would be a really nice exercise to redefine what application server actually is. So right now, for me, it is what I told you. I don't care about the technology. I focus on business. And whatever happens on the application server, I really don't care. And I can rely on stable APIs. This is what is really important to me, because if you are doing Java for 20 years, learning each week something new is not fun in long term if you have deadlines. If you don't have any, it's fun. Agreed? So, the default Java EE architecture for me is don't make me think. It's not like someone comes into project and introduces 50 aspects, 30 annotations, and everything is loaded on demand. It's not. We build something deadly simple. This is the mode. And actually, also funny at the AHEX in Munich. So, at the first day, everyone challenged me how to do this, how to implement plugins, how to implement whatever. And I hacked more and more stuff, and in the end they say, this is too complicated. It's like, yes, but you asked me a question, and I hacked this for you, and now you see how it works, but you don't need it in every project. A usual Java EE project is really extremely simple, should be. What is the problem? The problem are ivory towers sometimes, and sometimes consultants who like the technology more than the business logic. And this is actually the core problem, that it's a lot easier now to think about logging, aspects, transactions, than about the business logic. It's more fun, for sure. This is actually the reason why there are no business, or almost no business open source projects, but a lot of technical open source projects, because everyone loves technology and no one loves business, okay? So don't make me think. So what it means in Java space, I hacked it several times on stage. Add inject is the most important one. Qualifiers are already rare. You don't need it a lot in the projects. Then JSON is the way to go. So we can call it JSON, how it's called, API, no, technology agnostic API. It really is, and it's reasonable. SOAP, I would say, I didn't use SOAP for ages. I mean, yeah, you could introduce SOAP. It would be still microservice because it's somehow technology agnostic, but I think the way to go is really JSON and even JSON. And there is a component model I'll show you in a second. Entity control boundary is that simple. We use it for ages, and turns out it also fits well to the microservice idea. And for me, conventions are paramount. This is actually what we can even improve in Java 8 to be even more conventional, because configuring something over and over again is completely boring, and this is what I really hate. So, and the last Airhacks TV, it is recorded, you can watch it. There's someone asked me a question, yeah, Spring is more flexible in case of transactions. And my response was, if I see in a project, Java 8 project, the keyword transaction, it is a defect to me. So the default is so good, so if you start with the first component, it starts transaction, and the transaction is cascaded to everything on the back end. So, you know, just mentioning transaction in the source code is already a very bad sign. It's like, okay, interesting. So they try to be more flexible in Java 8, it's like, this is too flexible. So the default is just enough. So why it is so important? Because productivity. I think the only thing which we should care about is productivity, and not some strange things which no one pays for. Still everyone on my side? This is amazing. So it cannot be, because so this is the pattern boundary control entity. Control is optional. This is an EJB which starts transaction. In Java 7 you can put transactional request code, will be similar, but one annotation is less than 2. Then is why I still use add stateless. Control are just POJOs, and entity are persistent objects or POJOs. And what happens more and more, there are no DTOs, so they died completely in my projects. Instead, sometimes I use JSON objects to which are converted from entities. So standard is JAX-P, you get JSON for free. If it's not flexible enough, we introduce JSON-P or this new JAX-ORS JSON API. This is the default architecture. And the funny story is, you cannot remove anything if you write Java code. This is the simplest possible thing. Nothing can be simpler. Okay? So this is why I say, okay, if someone says Java is not suitable for microservices, I go, what is then? I mean, show me something else. And nothing was there yet. So, so actually, we can call this a microservice because business component, very simple. It could be a perfect microservice. From my perspective, it is not pragmatic enough, because if you do it on that level, you will end up having what we always had a problem. You have two services running remotely, and you have to orchestrate the services, which is not a huge problem, except transactions are always the problem. Just imagine I would have to have, for the DevOps here, a flight service and hotel booking service is always the classic example, right? So then I will have to orchestrate, try to book a flight and the hotel at the same time, which is somehow challenging, or not even possible, I would say. So I would say a more reasonable thing to do is to bundle multiple components, put them, I call them subsystem. Now we'll call them in a microservice, because the name is nicer, but what it actually is, and always was in my Java 6, Java 5, and Java 7 projects, a war. In Java 5, not. Java 6 and Java 7 was a war. Web archive. So in Java 7 land, in Java 6, microservice to me is a war. A war comprises a view components, very view components, which are highly independent from the others. This is what I always said in my Java 8 talks. Absolutely compatible with microservice. Can you see any incompatibility so far? Okay, so I'm not crazy. This is very good sign. Not crazy yet, okay? Oh, very good.
The microservice definition says that it has an own process, and in this case we don't have it.
Oh, I don't, why not? Application service or process?
Yeah, you have one process for the application which spawns threads, but it's one process.
Yes, one process per microservice, what I get.
No, what I see is you deploy multiple WAFs on one application.
No, sorry.
Okay, then.
I'm not very good in slides. This is why I always prefer to code. But when microservice, I thought I create some slides, and this was a mistake I see already. So this is a business component. This is a one package, which the name should be, for instance, DevOps registration would be the package, registration, and there's three sub-packages, and the first one is an EJB, and then Pojo, probably a Pojo entity, one package. And this would be the definition of a microservice. This is very micro, or even femto already. But this is too femto, right? So what I would like to have is multiple such components within a war, and they are running on applications. This is my whole point. I wouldn't try to put, a micro things and run them in a process, because we will get the same architecture in 1999 with remote entity beans, which never worked, or Genie, which worked but was crazy complicated. And I don't like the idea to increase the complexity unnecessary just to be micro, or femto, or whatever. And I already see it on the horizon. The first consultants coming to distributing everything to be particular micros. Okay, good luck with orchestration. Agreed? And the orchestration from the technical perspective was never a problem. Always from the business perspective, because of CAP theorem and 2,000 other theorems. Agreed? You get a t-shirt, so I will throw it at you. So this is a very good question. No. You are glad you are not in the back, because I would have to put a stone inside or something. So the idea is war runs on application server, and I don't believe anymore shared deployment on application servers. They also talk a lot about this is just crazy, because what we save is nothing. So you have one war, one application server. Then I would get even further and say one operating system, and this is the microservice, because no one cares about wars, application servers. We care about apps. It's a whole stack. Agreed? So for me, it means self-contained wars. One server, one domain, one war. This domain doesn't matter. So usually Glassfish or Whitefly right now have domains. What it means, you have one application server, you can start multiple domains. So then you have the application server. On Docker, for instance, I have one Glassfish with one domain, or one Whitefly or one Tommy with one domain. And war on top. This is the process. No dependencies. I'm very particular about this. If you already have Java EE on the application server, the war should be skinny. So I try to remove whatever I can. Why? The smaller the war, the faster the deployment. And slow deployments is really, I hate it completely, because they damage the whole productivity. Agreed? So no dependencies and no jars. This is also what I see the trend. People start to put jars to wars, to modularize the wars. Like, it could be nice, but why? There is will never be a case where you replace just the jar within the war without redeploying the war. You will always redeploy everything. So putting more jars to the war just increases complexity without any added value. So you always will have to have a reason to put more jars to a war, and one reason could be you really have to have an explicit API or whatever, but there should be really easy to understand reason. And what I see in Java projects or Java EE projects, the reasons are not easy to understand. The reasons are more like, we need modularization, therefore we create 5 modules. No kidding. As in one project in a commercial client, we create something with 3 modules, and the architect told me, we have not sufficient modules. Like, how many modules would you like to have? So I will charge you per module then. Not per day, so per module, and you get 50 if you like. But it worked perfectly. So everyone was satisfied, but not the architect. It was too monolithic. And he's still not satisfied. Although the software is already 6 years in production, everyone's totally satisfied. The architect is really angry on me, because I only created 3 modules and no more. So Java design, no interfaces. They are gone. This is 95% business code. So if you see a Java project and it starts with packages, util, common, whatever, it's okay, what you are building here? Call it bureaucratic architectures, because developers think more about components than the business logic. A very few annotations, just POJOs, straightforward testing. Why straightforward? The first question is how to test the whole stuff. Just use JUnit. There's no difference between testing Java EE or POJOs. Installation. Now it starts interesting. So the usual download size of the application server is around 100 megs. So I downloaded several application servers around. There are crazier than this, but still, the Whitefly, Glassfish, Tommy, you get for about 100 megs. Installation is unzip. So I actually don't know any application server which is not unzip. So why it's so important? Think about automation. What you can do, download the application server, unzip, run it. Okay, very important. Shell script execution. So WebLogic, shell script. Whitefly, shell script. Tommy, shell script. Glassfish, star domain is also shell script. And this is actually, or in WebSphere Liberty profile is also a shell script. Or batch file is the same. I mean, the script. It's not like you have to, back then there were exe files or whatever. It was a black magic to start the application server. License files everywhere or whatever. Dongles, some even had dongles to start it, which was particularly interesting. Okay. Questions about this? So lightweight, let's say, what's the problem? 100 megs? So let's say if we had 10 megs, would it make any better? I would say I don't care whether the application server download size is 100 megs or just 3. These times are over. In 1999, it would be a huge difference, but back then, it was in the relation to now, it was like the application server were larger and the bandwidth was less and no one complained, right? Start time, 1 second to 3 seconds, and I started yesterday WebLogic, it was 10 or 15 seconds. So, but this was the largest on the WebSphere Liberty profile, one of the fastest. So I would say the majority of the servers start about around modern servers, 5 seconds, and this is the idle start time. And pure Java is the default. Some application servers have native optimization, but this is usually optional. Agreed? Why pure Java is interesting? Yeah, if you would test on Windows and deploy it on your micro environment, Pico environment, or whatever, it is really important to have it. Questions so far? No questions, it's strange. So, what I did then, yesterday in the airplane, so okay, no one will believe me. So what I did, I started Glassfish v4, the v4.1 actually, and attached with Visual VM. This was idle one, and this was actually not unclean Glassfish. All the servers I used them, and there were already some applications installed. It's not like it's very clean, no labor. It was they're actually I'm using them. But you can see an idle Glassfish was around 40 megs of RAM overhead. 40 megs of RAM, default configuration, the default was -XMX 500 meg RAM. So what it actually means, I think we can reduce it to about 20, but we come to this later. Then I had Tommy, because my current project is Tommy, 22 meg of RAM overhead. Then Whitefly 8.1 was 33. And WebLogic, I don't even know whether this is current. I found it on my disk and I use it for one customer. I was, okay, let's start this and see what this guy does. 52. It's the WebLogic 12, probably the name is Cloud something or whatever, or Micro Edition or whatever it is. Okay? So you can of course argue, okay, but if we start, I don't know, drop wizards, dwarfs, or witches, or whatever we have on the planet, it will just consume 5 megs. And I have to say, I never had a problem with my client. In no of my projects, someone came to me and said, we have to reduce the 20 megs overhead of the application server because it is too expensive. Never. It was more the case, the architects went crazy and forced us to cache everything, and we had gigabytes of RAM. And then they complained Java it's too bloated, do something else. Like, do you really believe millions of your stupid objects stored somewhere else will consume less memory? I mean, there's no magic still, right? Okay, so, and let's say we would start a small cloud for a project, 100 of such services. So what it means, I think the WebLogic would consume 5 gig of RAM, would be the overhead, and the Tommy 2 gig, right? So go to whatever store you like and try to buy 5 gig of RAM. What I only know, 2 years ago, I bought the most expensive RAM for my server, 32 gigabyte of RAM, Corsair, low latency, and I spent 180 euros. So what we're talking about, the project is, in best possible case, we can save, after all the optimization, 90 euros. I mean, even the meeting, just the calling the product manager is more expensive than thinking about overhead. And they say it all the time. Why are you using applications that has too much overhead? And it's okay, did you even measure this? So go Visual VM, attach to this, click Perform GC, and you see the idle without any, and just download and try it. Still agreed? If not, we can do it online right now. A bit boring. I actually want to do it on stage, like who would like to see this. Okay, so, and what I did, I started Chrome. Without any home pages, nothing. It's just my home folder, And I don't know why I have so many helpers for one window, but the main helper is already larger than the application server. And no one talks about micro browsers, right? Or Pico browsers. Chrome, perfect. Because probably it's a small application server inside. I mean, Safari will be the same and Firefox is also. There's just one tab. Okay? So, question?
Yeah, one, but you don't mention Jetty.
What?
Jetty.
Jetty? No. I delivered a talk at 33 degrees, I think, in Krakow, and I did actually talk about this. It was three years ago, and Jetty and Tomcat were about 2 megabyte RAM or 3 megs RAM overhead. Okay? So what it actually means, if you would introduce Jetty or Tomcat plain, it would consume in idle 10 times less memory than Wi-Fi. Having 100 instances, you will save 90 euros. This is actually the message. And it is actually a lie, because Tomcat and Jetty are not application servers.
No, the situation is, when I use Jetty, I'm also in control of what I've got in my stack. You are not in any control when you're using
Yeah, but this is different mindset. You like the control, I don't like the control. This is a really different mindset. This is a completely different story. And I would say your use case is more appropriate if you build clouds or services. Then I would like to be in control of the whole stack. If you are building enterprise applications, or no, don't have to be enterprise applications, just web applications, I would just focus on business logic, and I really don't care about controlling the stack. It's a completely different mindset. But this is conversation. It is like this. And this is why I'm really glad, because prior to the whole Java stuff, developers start investigation the first 2 weeks. What is the best of breed framework, or what we can here use? And I don't care anymore. I would like to have one transaction manager, which is reasonable, one JAX RS provider, one dependency injection. I don't like, to create the first day. I use Weld with CXF and with Hibernate because I like the combination. And on the first ticket, you will spend days, if not months, to fix this. So I would like rather rely on a standard combination of these services. Out of the box. This is my thinking, but I know there are different approaches. There's nothing bad or good, it's just how I see the things. Agreed? You get t-shirt for sure, because it was very heretic question. I won't throw it at you, because I will keep it here. Okay. Now the war packaging is the problem. So okay, I took a war from my current project and performed unzip. It took 200 milliseconds. And jar, 2 milliseconds, okay. And jar was about 200 milliseconds. So, okay, it cannot be the problem. I mean, okay, no one complain and say deployment is 200 milliseconds too slow. Do something about this, yeah? The problem was the war was so large that it took 40 minutes to deploy. But this was crazy. And the real problem while deployments were so slow was not that they were large. There were lots of, for instance, JPA entities with named queries which had to be processed by the database. There were lots of, stored procedure, no stored procedure was the other thing, was the statements that are prepared statements. Yeah, statements that are prepared statements, and they had to be processed by the database. This is the overhead, the scanning of the things. But the problem goes away if your wars get smaller. And of course, I use Maven everywhere. So standard Maven, standard default, 24 lines of POM. This is reasonable. And with unit test, my current project builds in 3 seconds. Integration test is the next stage, but unit tests with Mockito are very, very fast. So we never actually had a problem with Maven 3, it's just too slow. What I always had the problem in Java projects, the developers started to adding plugins in Maven. It's like, oh, we find plugin, and no kidding, some projects even generate websites with POM. All developers with all the numbers, probably Twitter accounts, whatever they have, and then it takes 2 days. Okay, but I mean, you can use Maven, you can even brew coffee if you like, but usually concentrate just on building, right? And also, this is not a part of the talk, but how I build things is I don't misuse Maven to do the pipelining. This is the job of Jenkins. So Maven clean install just run the unit test. Maven facesafe runs the integration test. And another Maven project is used to run the system test. But the, how it's called in microservices, orchestration pipeline is Jenkins. This is a set of jobs. Everyone agreed? Okay, some code. This is the last slide. This is why I'm glad now nothing can go more wrong because slides are gone. So now with everything is going to be crystal clear. So what we can do is the courses were announced, and this is courses. So let's create a very small. It's very fast, and I think the reason is well because I disabled internet. So this is the default setup for Java project. What we allowed in my commercial applications, if I work for a client and they ask me for help, the only allowed dependency is this. You get everything with this. The whole developer API is there. And anything else which is with scope test is allowed. And all runtime dependencies, we have to think about this. Because why not use what's there on application server? And this is what I told you, this is a different mindset. I don't like to control, I don't actually care which is on the application server. If my test is green and the application server is, in the performance of the application server of the application is reasonable, I'm happy. If not, I try to swap as early as only possible the application server. In largest projects, it's impossible to swap because there are political reasons, but this is not reasonable. Agreed? Still everyone? Strange that everyone agrees. So we have this, and I did it in Malmo too late because you probably know, right? What is actually the JSON configuration? I wouldn't hack too much. Ajax parlays would be the app. Courses would be the. I'll just put it here. Let's create parlays. Parlays. Then courses would be the component and the boundary within the component. This was the misunderstanding from courses resource. Call this courses resource. Looks nice. And the JSON configuration requires this, extends application, and I can expose it having application path. And usually it is just resources. Don't make me think. It could be a version number, but it's a longer discussion whether there's a version number or not here. And the courses resource usually has a path, a conventional path. Don't make me think is a plural of course or courses, because we would like to expose all the courses. And string all get. And of course, our courses are micro, Pico, Nano. I forgot Nano. Next year. Next year, DevOps, see you with Nano. So run, ask me which application server to use. I use Glassfish Whitefire. It doesn't suggest Tommy. The reason for this is Tommy is not Java 7 yet, so this is the only reason. And I have more Whitefire running, but this is why I would like rather use Glassfish. I installed this empty. This is actually a good sign. There is no resources, courses. So you have your microservice. So this is what, it starts incredibly fast with a full cycle with Maven and exposed REST endpoint. So I would argue, whatever platform you're using, you will spend more time, more configuration, and more thinking about what service to use on the backend. And what I got okay, actually the last week, I will interview several startups using Java EE for micro whatever, and they say, okay, you can interview us, because usually it's a huge deal, you know, with NDAs, whatever. But on my blog, you will find some interviews which use this technology, and they say, what we really loved is productivity. This is actually the main point, not like Java EE or whatever. This is actually nice. So any questions to this? Of course, no one uses strings. Like, say, okay, if you would use proper microservices, you could use JSONs, okay. Of course, it's also possible. We could use a JSON object and say, JSON create object builder, and JSON array would be better, but JSON object is faster right now. Say courses and micro and build. It's a new API, and you don't see anything. Could be a cache, but it should work. So now it should remember. Still not. No, vagrant comes later. So curl, what was it? HTTP localhost. This looks similar to Palais from Stefan, right? So localhost Palais. What was it? No, courses, resources, and what else? Still, even better. So something happens behind the scenes. So I don't see add courses micro. This actually should work. Add courses micro. This is key value pair. I would expect something, but not this. I could use default the JSON. Somewhere. Oh, this was just. I guess this was a browser caching issue, but as you can see, this is JSON with the default, and of course I could expose as many formats I like. So I did it several times. So we can just skip it. So it's very simple. So if you would like to access more services, what you will do, you will have to think about, okay, is it now, and for instance, an EJB, so you get transactions for free. And in the boundary, you would usually get a real boundary, and this would be the courses service, and it would look like something like this. This is actually optional. You can remove it. And here, the business logic. Agreed? You have to. This will be the business logic, and if you have more to say, you would inject here the POJOs, and in Java 7, this would work, courses, service, so this would work. In Java 6, it wouldn't. Yes. So this would work in Java 7. In Java 6 it wouldn't, because then we would have to create an XML file, but don't worry, it is not too big. Beans XML, and in Java 7 I say all, whatever it founds in war should be injectable. And this is actually the deal. All, so now it works. So you see, as soon as I introduce an EJB, everything goes better, right? So, so I have here an EJB, which actually, this is the default architecture. REST exposes a service. The service is actually an EJB, and usually it's just that. If you, in this particular case, you have just to decide whether you put stateless here or stateless here. I put it on both cases because I get most application service monitoring for free, so I see what happens behind the scenes, which I really like. So, and this would be a microservice. So it is deployed. So if I clean and build this, which is a Maven behind, so NetBeans just runs the standard Maven build. I get in target a war, and this war is basically empty. So if you go there, you will see it's about 5 kilobytes or whatever it is. Junk, what was the name of the courses? Target. So the courses is 4 kilobytes, yes. So it is micro. Agreed? So now, yes.
How do you keep it this small? If you look at your own example of doing first the flight, then the hotel, or in whatever order, it's still manageable. But as more business functionality comes into it, it starts to grow and grow and grow, and that's when you start to cut off and have to handle orchestration, right?
Yes. But my point was, what I always said is, teams should survive with a pizza. And because of Conway law, one team delivers one piece of logic, and this is, in my case, was always a war. So if a small developer team, 1 to 5 developers working on something, and they deliver one war. And the war is usually small. And because it's one team, it has some self-contained business context on however you can call it. My hope is, or the hope of every architecture is that the teams can work independently. So if you orchestrate, the wars, you get coarser grain APIs. This is actually the idea behind. Okay? What I heard is a lot. Teams should survive with 2 pizzas. I heard already recently on several talks. Okay, this is twice as big as what I usually say in Java. I agreed with this, and I mean in practice, if you have JSF or whatever, you will need the libraries. So the war is going to be a little bit smaller, bigger. But this I cannot remember any wars larger than 20 megs or something. And we really are very particular about the external dependencies because they introduce other trouble as well, but there's not enough time to talk about this right now. So, and now, what I never talk about is Docker because I thought no one is interested in it, and I'm using Docker for ages on my server. So actually, whatever you see on my server is a Docker. So, and prior to Docker, I use KVM, and before then Oracle VM, and which is Zen-based. So I automated everything. The only difference was with Docker, it starts in 2 seconds with virtualization a few minutes. This was the only difference to me. So how it looks like. So this is not how Docker should be used. This is how I use Docker on my server. And I can show it because it's my server. And yeah, this basically is. So what I did actually, I created a base server, base Docker image. And this base Docker image has some tools which I always need. wget, unzip, gettext, and OpenSSH server. To have a SSH is actually not necessary, but nicer to me. Password is not top secret and is not available from outside, so it is just the internal network card. And what I did, created a small application, ping. It is on my GitHub account. What it just does, you can ping the application and you get memory back and the CPU usage to see how it works. It's a Java 7 API. I need a JDK 8, update 20 is older, but this is actually what I use right now. And it sets up the path and links to NAS1 because I use NAS1 for scripting, for automation internally. So, and this is the base Java image, and let's go to my, let's say, X-ray, which is a statistic of my blog. It inherits from base Java server, and the base Java server, is what you already saw, and I'm just adding Wi-Fi 8.1 to it, and just unzip it here. So what I started with is to downloading Whitefly from the Whitefly page. Was like, actually, it takes too long. So what I did, I put it in a folder and committed to a Git. So all the folder is actually a Git repository, and I can do whatever I like on my machine, go home, say git pull, and restart the machine, and I have the newest stuff on my server. This I'm using for actually more than a year, so I started really early with Docker, and I thought no one is interested, and then someone said, hey, you have to talk about Docker. So, okay, we can talk about this, but it's actually not that exciting. It runs on server, right? So, so we add, there is some configuration going on, and really great about Docker is I exposed all the ports. You see also the 22 ports, and I can start from this Whitefly could start 5-10 times, and map the ports later. So what I do, for instance, I can start Whitefly for a parallel to production for integration tests and see how it works, and this takes seconds. So also workshop registration is also such a file with Tommy. Why not? I mean, we have Java 7, so Java E, so it should work. So where is it? Workshop was here. So this is a Tommy. So what's my workshops? This is also the registration app is deployed here. So we have some satellite. It is Hazelcast caching. So, and the most interesting part probably is this. So what this actually is, I'm starting Jenkins running on Docker, but this Jenkins contains scripts to manipulate Docker. So I can put this on server and run, and it will start and orchestrate all the processes. So this is like a meta Jenkins. So a little bit strange, but it works perfectly well. And then I heard more and more talks about orchestration. And I says, actually what I'm doing for a year, orchestrating, but I never call it orchestration. I call it always automation, so I have to change my wording to be more successful, but I'm working on it. So now I'm orchestrating everything on the server. And it always worked well. And what I do is a secret, you have everywhere are bash files, but the bashes are a little I don't like it because yeah, there are some corner cases where it does not work. So what I use more and more, and last one, there's a secret knowledge in, no secret, JJS. In Java 8, you can use NAS1 JavaScript for command line automation. So I use, and you get JSON parsing for free, you can use system commands, curl, it is a lot easier. So I'm just migrating from Bash to NAS1, which is even more exciting. So, but the point being is, how it looks like, I developed my application exactly like this. Then there were, at one point of time, either it will end up here if it's a prototype, then if it works on my machine, I will pull from server and it is on the other machine, and I can just decide whether I will start it on on the same port or a new port for tests. This is the one mode. If the module is already in production, what you could do, I can push to Git. There is a Git, how it's called, hook or something, which tells Jenkins build the whole stuff, and Jenkins perform the orchestration. Okay? Agreed? And there is a Condep application running, and this is the Jenkins. There is actually my blog running with all the parts. This is very small Angular application I built. It's also open source. It's a simplistic one. But it helps me to see what works and what doesn't. And the ping application is a counterpart called Floyd, of course. And the Floyd scans all the ports and shows me which application servers are running. But for me, the application server does not matter. Each application server, whether it is Atomy, Whitefly, Payara soon or whatever, each of the application servers is for me the app. I don't care about the application of the operating system anymore. And I think this is how the whole microservice was actually defined, right? So this is all about the service, not the application server. But the point being is, for me, I could do whatever I like. This is my server. But this was the fastest possible way to deploy the applications I need. So I spent a few hours and I have a running application. Any questions about this? No questions?
How do you manage the different environment configurations? So QA phase, you want to use different database and in production?
Oh. What I do it the primitive stuff. What I'm doing is I have 2 Docker containers. I'm linking them hard. This works for me very well. What you should do, there are different. If you have to have something like database or access to log files, you can link to a Docker image with volumes. And there is a pattern called ambassador pattern, and this is the best one, but I don't need it. So I would do it for commercial clients, but not for me. What it actually means, you have something like a proxy. So you're talking to a proxy, and everything which the proxy knows where to dispatch the stuff. And the linking for this was, I don't know whether you have experience with Docker or not, what actually happens if you link to other containers, basically all the IP addresses and port numbers, whatever is exposed in the other container is immediately available to your container. This is what linking actually does. And environments, I had 2 environments. I just have tests and production. And what's interesting, I wanted to have integration environment, but the problem is what I recognize is the whole server boots now in about 5 seconds. And it's so fast that I don't even see the progress bar. So this was Red Hat Enterprise and CentOS. It was CentOS and Red Hat Enterprise Linux. So you don't see even the progress bar, you see the login. So I log in, and after I would say 20, 30 seconds, you see the service. So what I actually do is git pull and reboot. So everything is offline for 50 seconds, but who cares if it comes online again? So this is actually, if the deployment is fast, it changes everything. Okay, so it's a really interesting experience. So, what I would do is the mapping. So what you would like to do is to start the new service on a different port, and I have some name scheming, so add 10 or whatever, and you know then, okay, the port 8090 is my integration port. You can test with this. If you're happy with it, then Jenkins should, promote everything to production. And what you also will have to have is something like a smart load balancer for this. For it's what I don't have. This is fast enough. By the way, my server, I spent about I think 2K euros with SSDs and everything, or serve on Amazon. And this is so fast I cannot. This is why I have so many Docker images, because what I can do, right, is I spend 30 gigs, have 30 gigs of RAM, a Xeon, and it runs like crazy, but it's idle all the time. So I start more and more Docker images, but it still looks great. And then I hear all the time Java is too complicated, too large, or too heavy, whatever. Not my experience. So actually. And how it works, you can, in Docker, what is great about Docker, this is the image, and this is something like POM XML, I would say. So it builds the image, and then the image is available, but now is the great question. So if you test something and it doesn't work, so if I go here to my Docker, back to Docker, so all the images, so I built some image, it's not 4 minutes, and it was in the train today morning, but the last image is about 1 year back, and it was not the first image because it started on the server actually, but you have all the images, and you see a satellite, block, X-ray, is all my versions, and if something went wrong, I can just start the previously working image. So it is less critical to be, bulletproof, because if this version doesn't work, I have a fallback, and this is a full image. This is a great story. Each build of the Docker file creates a new image with potentially new version. If the recent version doesn't work, I can just fall back to the recent one. And what you mentioned probably, what you probably wanted to, or I hope so, the problem is always if you have relational database, there is no more so funny. This has nothing to do with Docker, because what really breaks more and more relational databases is too long alter tables. So there was one customer told me 2 weeks alter table. So then there's nothing more, continuous. So forget about continuous deployment. If you commit something, you have to wait 2 weeks until it's in production. I mean, this is no more micro, I would say. Questions? Agreed? For my services, do nothing. The question is, what I do for the API for my services is not true. What I do for my services is, for RESTful web services, is the following. For each path, I I create a method with options. So if I have a get, let's say, courses, I would create the same method with options. If someone calls options, gets back a skeleton object, template object, or example object. This is the best documentation so far. And the view commercial clients, view commercial startups, I work with them. That's what we introduced. It was actually very good, because you just access an URI with options instead of get, and you get a sample object back, and you can send it back. That's actually what I really do right now. So this is the one, and there is a nice API. I will have to. I forgot the name of the project. It is. Then I will blog about this. But it scans the annotations, creates a JSON file, and then there is a HTML5 application that creates a clickable API. Swagger? Yes, but all the tutorials from Swagger were a little bit complicated, and I hope I found an easier solution to deal with. If you think it's interesting, I will put it on my blog. But what it actually did is a Maven plugin which scanned all the annotations, created a JSON file, and this JSON file was accessed by the HTML5 client. So this was actually the whole magic. And this worked great for not too complicated resources. If it was too complicated, I get some issues, but for default works well. Was this the question? Yeah. In my case, there's also no delay, because if I'm deploying, I have the JSON. So what you're trying to say is that the Spring is a little bit faster than Java. Not faster, I mean, faster for deployment. Okay. The default way in Swagger is actually to hook up to the JAX-RS application, and then you get it immediately. But I don't like it, because I don't like that the Swagger knows about my application all the time. It's just like it tries to to put hooks to my JAX-RS runtime, which I really dislike. So I think what I do right now is, what I really like is, in my build process, it scans and creates the JSON if something changes. Because the JAX REST services do not change a lot. It's not like, in each deployment I have a new service. It is fairly stable. And this is what I do right now. But yeah, okay? Yes, this is with the this is actually, okay, there is a not standard weight called WADL, Web Application Description Language, comes with Jersey, this you get for free. So it's exactly what you get, but it was not sufficient. So you get, list of all services with all parameters, and still, how to invoke this. It's still a lot to do this. And actually NetBeans generates a test client from this automatically. But what I would like to have is more like if you invoke a REST service, you get back the example how to use it. You can set it back and something happens. This is what I'm thinking about right now, and this means work. You have to think about this. And for instance, and what I also do, always put the execution URI or whatever URI on that you just only have to look at the object to know what happens. So I use it more like state machine. Sorry, the question's too long, come to me later. Other questions? No other questions, then you can ask still. So there are the images, and if I would, for instance, would like to build a new Docker. Oh, this is in wrong folder, sorry. Closed by a remote host. Someone hacked my machine. Okay, so all the services are running, and what I actually wanted to show you is if I would like to build something, for instance, my blog, I would say build. It's really hard to hack something. So, and now it uses the REST API, uploads the whole block, and everything is cached. It didn't change a lot, so the whole image is built. Now I could start the image. This was actually the huge. Actually, I built the whole microservice with operating system and the block. So one small tip, if you're using Docker and Java EE, I think it is a good best practice to put the wars at last. So if you would start with this, it will change all the layers. So the more frequent something changes, it come later in the Docker file. So this is actually there was PWO deployment. So this is what I did after a while. So because it is not likely that the white file will change every day. It will change, I don't know, 3 times a year, but not every day. So it will remain the same. So then Docker will cache it, so the build will be really fast. So I put the wars, my wars, also the modules, last. But I can see this is what I do, and this is actually absolutely compatible with microservices. And what I would improve right now is not use Git for distribution rather than Docker Hub or a Docker registry. So push from my laptop to the registry and pull on the server would be even nicer. But what this actually means, I have the whole Git registry as well. The Git, not registry, Git history. So at any point of time, I can just switch between versions. So this is what I'm doing, and then the amazing story is actually microservices. And I hear a lot of application server will die because, I don't know, we have microservices, I can get it. So what will die and why will die, right? And actually, if they would die, it would be no different. So then I will use something else here, but it will be exactly the same approach. I will try to create whatever magic technology we get, which is nicer and more productive than this. And what I wanted to spend a little bit of time orchestrating with Java 8, but I think in the next few days or weeks will come a free article on OTN with what you can do with plain Java 8 and Java 8, sorry.
What about development? I'm thinking about hot deploy, JREL, and that kind of stuff.
Hot deployment, I actually always use this. What I do is here without any plugins. So this is stock NetBeans Java EE. This is what I use. With Tommy right now, commercial project is Tommy right now. It works like this. Whitefly and Glassfish and WebLogic just works. And if the project is huge, you need hot deployment. But this is no more micro. And this is what I'm talking about. If you have huge ears, I mean, you have another problem. So but this has nothing to do with micro, macro, or whatever. It is not reasonable to have huge ears. And huge are not reasonable at all. So what is reasonable? Having small modules worse. So if you are reasonable, you have your microservices or Pico, whatever we get next year. But at one point of time, if we will all exaggerate with the micro, Pico, whatever, what I guarantee you, 2 years later, we'll get macroservices. Because if you make everything remote, and you say, oh, you only need another orchestration framework, whatever, reactive programming here, it's a lots of work to be reactive, and there's lots of work to understand all what happens behind the scenes, to orchestrate it without transactions. Okay? So, thank you. We have 1 minute left. Last question? Any question? Great question this time, so thank you, and see you next year. And I hope these slides were not too confusing. And yeah, if not, see you next year. Okay, thank you.